Hi, my name is Priya Ganala, and I will be going over Honors Chemistry Chapter 1, Matter and Change. Let's get started. So what really is chemistry? Chemistry is the study of the composition, structure, and properties of matter, the processes that matter undergoes, and the energy changes that accompany these processes. Chemistry is a physical science. It focuses on non-living things. Instruments are routinely used in chemistry to extend our ability to observe and make measurements, like the microscope we see right here. In all areas of chemistry, scientists work with chemicals. A chemical is any substance that has a definite composition. For example, water, carbon dioxide, sucrose are all examples of chemicals. And in chemistry, we have different types of research. We have basic research, which is carried out for the sake of increasing knowledge, such as how and why a specific reaction occurs, what the properties of a substance are. And the other research is applied research, which is generally carried out to solve a problem. In applied research, researchers are driven not by curiosity, but by a desire to solve a specific problem. Let's move on to matter. Matter is anything that has mass and takes up space, also known as volume. Mass is a measure of the amount of matter, while volume is the amount of three-dimensional space an object occupies. So these two factors, mass and volume, are what make up matter. Matter comes in many forms. The fundamental building blocks of matter are atoms and molecules. These particles make up elements and compounds. So an atom is the smallest unit of an element that maintains the chemical identity of that element. Element, however, is the pure substance that cannot be broken down into a simpler, stable substances and is made up of one type of atom. For example, carbon is an element and contains one kind of atom. A compound is a substance that can be broken down into simple, stable substances. Each compound is made from the atom of two or more elements that are chemically bonded. Water is an example of a compound. It is made of two elements, hydrogen and oxygen. The atoms of hydrogen and oxygen are chemically bonded to form a water molecule. A molecule is the smallest unit of an element or compound that retains all of the properties of that element or compound. So in this figure, we see both elements and compounds are made of atoms. So we have the hydrogen atom, oxygen atom, carbon atom. And this is a model for sucrose, which shows this. So let's move on to properties. Every substance, whether it is an element or a compound, has characteristic properties. Chemists use properties to distinguish between substances and to separate them. Properties can help reveal the identity of an unknown substance. So properties are either intensive or extensive. So extensive properties depend on the amount of matter that is present. For example, we have volume or mass. Intensive properties, however, do not depend on the amount of matter that is present, which is boiling and melting points and density. Those are all intensive properties. Properties can also be grouped into two general types, physical properties and chemical properties. Physical is a characteristic that can be observed or measured without changing the identity of substance. So color, length, volume, opacity, these are all physical properties. They don't change the identity of substance. Chemical properties relates to a substance's ability to undergo changes that transform it into different substances. So for example, flammability, reactivity, toxicity, these are all chemical properties because they change the identity of a substance from the original. These are known as chemical. Talking about changes, we have physical changes and chemical changes. Physical change is a change in a substance that does not involve a change in the identity of a substance. And chemical change is a change in which one or more substances are converted into different substances, which is also known as a chemical reaction. The substances that react in a chemical change are called the reactants, while the substances that are formed are called the products. And then we have changes of state. A change of state is a physical change of a substance from one state to another. So the different states are solids, liquids, and gases. A matter in the solid state has a definite volume and definite shape. The particles are packed together and cannot move. So as we see here in this model, the solids, the particles are packed tightly and they're unable to move. Matters in the liquid state have a definite volume but an indefinite shape. A liquid assumes the shape of its container. So the liquid in this glass is assuming the shape of the glass. And in a liquid, particles are close but can move past one another, unlike a solid, which cannot move. Matter in the gas state has neither definite volume nor a definite shape. The particles move rapidly and are at great distances from one another. As we see in this model, the particles are far away from each other and they move rapidly. Those are the differences between the solids, liquids, and gases. And these particles, the way they move and how they're associated with one another is what makes up the states. Moving on, we have mixtures. A mixture is a blend of two or more kinds of matter, each of which retains its own identities and properties. So we have homogeneous mixtures, a mixture that is uniform in composition, which basically means that the parts of the mixture are fully mixed together. You cannot separate them. Heterogeneous mixtures, however, are a mixture that is not uniform throughout, which basically means that the parts of the mixture are remained separate. So for example, we have coffee here. A cup of coffee, it has different ingredients in it. We know that. But however, we are unable to remove the different parts of it because it is homogeneous. It is uniform in composition. For example, we have cereal here though that has its different parts, milk and cereal, but it is a heterogeneous mixture because we're able to separate the different parts. Those are the differences between the mixtures. Moving on, we have pure substances. A pure substance has a fixed composition and differs from a mixture in the following ways. Every sample of a given pure substance has exactly the same characteristic properties. So chemists use this basically means that these properties are so specific that they can be used to identify the substance. In contrast, the properties of a mixture depend on the relative amounts of the mixture's components. And the second thing is every sample of a given pure substance has exactly the same composition. So unlike mixtures, all samples of a pure substance have the same makeup. For example, pure water is always 11.2% hydrogen and 88.8% oxygen by mass. This never changes no matter the amount of substance. And pure substances are either compounds or elements. So let's look at this model. We have matter, and it can be separated by whether it is separated or not. So if it is separated, those are known as mixtures. And mixtures is separated by if its composition is uniform. If it's uniform, we have homogeneous, which we know. And if it's not uniform, we have heterogeneous mixtures. And then if we look at the other side, if matter cannot be separated, it is known as pure substances. And it is further separated by, can it be decomposed by ordinary chemical means? If it's a yes, that means they're compounds. If it's a no, that means it's an element. That's how we can fully look at matter as a whole. Let's move on to the periodic table. The elements are pure substances that cannot be decomposed by chemical changes. The elements serve as the building blocks of matter. Each element has characteristic properties. The elements are organized into groups based on similar chemical properties. This organization of elements is the periodic table. So let's get into it. This is a periodic table. Each small square of the periodic table shows a symbol for the elements and the atomic number, as we see here. So hydrogen has an atomic number of 1. The vertical columns of the periodic table are groups. So these are the groups. So we group 1, group 2, group 3. These are the groups. And notice that they are numbered from 1 to 18 from left to right. Each group contains elements with similar chemical properties. The horizontal rows, however, are known as the periods in the periodic table. And physical and chemical properties change somewhat regularly across a period. This is basically, to sum up, what a periodic table is. They are further separated by the different types of elements. So let's get into that. So we have metals, which are an element that is a good electrical conductor and a good heat conductor. Metals are hard, malleable, ductile, and have luster, and they're usually solids. Non-metals, however, are an element that are poor conductors of heat and electricity. They are soft, not shiny. They are brittle, and they can be solids, liquids, or gases. And we can see them here. These are the metals and these are the nonmetals. And the last section we have here are the metalloids. There are not that many metalloids, but a metalloid is an element that has some characteristics of metals and some characteristics of nonmetals. They are less malleable than metals, but not as brittle as nonmetals. They are semiconductors of electricity, and they are solids at room temperature, and some have luster. The last thing we want to know here are noble gases. The noble gases are the ones in group 18, as we see here. So helium, neon, argon, these are all noble gases. And noble gases are, these elements are generally unreactive, and we'll get more into that later. This pretty much sums up chapter 1 of Chemistry Honors, Matter and Changes. So thank you for watching.